In this lesson, we're going to go over Unit 3, Acquisition 4. Our topic today is solubility rules. You will need your Honors Chemistry resource packet, and there is a page that looks like this. It says General Solubility Trends at the top, and then there's a solubility table at the bottom. So make sure you grab that because we will use it for today. So first, let's talk about what do we mean by solubility. We've talked about that word soluble before. We said ionic compounds are soluble in water, meaning that they can dissolve in water. Solubility determines the amount of solute that can dissolve in a given amount of solvent. How much solute can dissolve in a given amount of solvent? Solute is the substance being dissolved. So let's say we were dissolving an ionic compound in water. We were putting sodium chloride in water. The sodium chloride, which is table salt, would be dissolved. Sodium chloride would be the solute. The solvent is the substance in which the solute is dissolved in. So if we go back to that example about sodium chloride in water, sodium chloride is table salt or any ionic compound, any salt. Whatever is being dissolved is the solute. So the salt would be the solute. What it gets dissolved in would be the solvent. When we say something is soluble, this just means it is capable of being dissolved. If it is insoluble, it will not dissolve. So why does this matter for ionic compounds? When we continue with this acquisition, you're going to have to include the state of matter when we write an ionic compound reaction. You're also going to need to predict solubility in order to do net ionic equations, which is our next topic. So let's say you have to predict the products of an ionic reaction, and it says to include the states of matter. If it is a solid, we would put an S. We would use this for an ionic compound that is insoluble. Also for metals. So let's look at a few examples. Let's say we were doing a reaction with aluminum, maybe a single displacement reaction. Aluminum is a metal and it is going to be a solid. Same thing, let's say we were using like iron for a reaction. Iron by itself is a metal, so it would get an S after it to indicate that it is a solid. You can also have ionic compounds that are insoluble, and that's where our solubility table comes into place. So across the top we have some cations, and down the bottom we have some anions. Let's say we had something like lead 2 chloride. We would find lead 2 along the top, find chloride along the bottom, and we would see where it intersects. Lead 2 chloride is insoluble. So if you were writing lead 2 chloride in an ionic reaction, it would get an S after it. If it is a liquid, it gets an L. The only time that we're really ever going to use liquids is for water. We could also have gases. Gases would get a G. We would use these for some non-metals, like diatomic hydrogen. Diatomic hydrogen is a gas, so it would get the G. Here is a nice image of all of the elements that we would use the G for gas. So the elements in yellow are going to be gases. Lastly, if we have an ionic compound that dissolves in water, we call that compound aqueous. And then it is going to get an AQ. We're going to use this for compounds that are soluble in water. Going back to my solubility table, let's say I had lithium bromide. If I find lithium and I find bromine, see where they intersect. Lithium bromide is soluble. Since it is soluble, we would write the AQ afterwards. All right, let's do some practice. Determine the state of matter for Alright, first one, sodium chloride. Since it is an ionic compound, we can go to our ionic compound table. I'm going to find sodium, I'm going to find chloride, see where they intersect. Sodium chloride is soluble. So that means it is an aqueous solution. It gets an AQ. Magnesium. Magnesium is a metal. Metals at room temperatures are solids. Potassium hydroxide. Find potassium across the top. Find hydroxide across the side. It is soluble. Since it's soluble, it gets the AQ. Water is a liquid. L for liquid. E, magnesium carbonate. We find magnesium across the top. We find magnesium across the top, carbonate along the side. See where they intersect. Magnesium carbonate is insoluble. That means it is going to form a solid. It won't dissolve in water, so we're going to see that ionic compound precipitate as a solid. Metals by themselves are always solids. And last one, aluminum hydroxide. Find aluminum, find hydroxide, see where they intersect. Aluminum hydroxide is also insoluble, so it would get an S for solid.